Hello, Math 7 students. This is video 3 of our 6th grade review, Unit 2, Lesson 5, Defining Equivalent Ratios. You'll remember in our last video, we talked about our tuna casserole recipe. We practiced finding a bunch of different ratios that would taste the exact same as Mom's recipe. We did twice the amount, half the amount, 5 times the amount, and 1/5 the amount. And we also were able to kind of work backwards and say, what if I'm using this amount? How many batches am I making? So we worked forwards and backwards on all of those equivalent ratios. And now we are ready for the Are You Ready for More? Now we're going to be looking at the size of dish that we're using. So to get started, it says the recipe says to use a 9-inch by 18-inch baking dish. Determine the length and width of a baking dish with the same height that could hold twice the amount of casserole. Before we dive into that, let's just kind of envision a 9-inch by 18-inch casserole dish. So I'm going to draw a picture of a rectangular 9-inch by 18-inch casserole dish, and I want you guys to include that in your notes as well. Okay, so I've got this casserole dish, and I'm going to go ahead and label the sides too. This is like the 9-inch one because it's the shorter side, and this is the 18-inch one because it's the longer side. Okay, so 9-inch by 18-inch. So, remember, if I'm going to be making twice the amount of casserole, is it all going to fit in the same dish? Probably not. If we have double the amount of food, it's probably not going to fit in the same dish. So we need to figure out what are the dimensions of the dish that are going to hold twice the amount of casserole. I want you to pause and think about this now. So online learners, you're going to pause the video and start thinking about that. Maybe draw a picture. In-person learners, you're going to start discussing with your group. How big would this dish have to be? All right, now that you've paused the video and had a chance to think about it, and our in-person students have had a chance to discuss, what would the dimensions need to be? How big does this pan have to be to fit 2 times the amount of casserole? What do you think, Jackson? Yep, how big? Call on someone. It did tell us the exact size of the pan. Let's go back and look at that recipe, and that recipe says transfer into a 9-inch by 18-inch baking dish. So it did tell us in the beginning. Just do the same thing? What's the same thing? Yes, however, that's for the one single batch. Remember, we're making twice the amount of casserole. What do you mean by 22? Look at our pan size, 9 inches and 18 inches. So now I need to go twice the amount of casserole. How big is that pan going to have to be? Let's go to Savannah. 18 by 36. Who agrees? 18 by 36? Yeah? Most of you agree? You're all wrong. Great thinking. It is really awesome thinking, and it's the exact same way that I thought about the problem too. But let's visualize this. Watch on the screen. Uh-oh. There we go. Nope, that still didn't work. There we go. Here's the pan, right? That's just going to be one casserole, though. And if I need to make double the amount, then I'm going to need double the pan. Right? Now, be careful. I want you to think about the dimensions that you created, though. Because you all said, well, that's going to have to be twice as wide and twice as long. But if I make the pan twice as wide and twice as long, that's going to be 4 times the amount, right? Kind of interesting, huh? Not quite what we expected. So, well, you tell me, what would it be? If this is 9 inches and this is 18 inches, but I only need twice the amount, do I need these extra pieces here? Nope, I don't, do I? We can, yes. Hands down for a second. Hands down. So 9 inches by 18 inches, but this is an extra 18 inches. And this will be one casserole. This will be the second casserole. So will that work? Yeah. Let's write that one down. Do you see it now? That's not the only way that we could have done this. Gavin R has another idea. He says, well, what if instead of making it a really, really long pan, what if I looked at it like this instead? Oh, here, we'll keep that over there. What if I had, here's the original, and instead of making it longer, I made it a little bit wider like that. So again, here's the original, 9 inches by 18 inches. Only how long is it? It's not just 9 inches, it's another 9 inches. So we could also do 18 by 18 inches. Do you see it now? Okay. I know. I know it's confusing. It made my brain really, really hurt, which is why I need another day to think about it. So with that in mind, think about the second question. Half the amount of casserole. Again, let's remember what one pan is going to look like. But do we need that whole pan? If I have half the amount of the ingredients, is it going to fill up that whole pan? So think about the size of pan that we're going to need. Try it again. So pause the video, give yourself enough time to think, and in-person students are going to discuss with their groups. All right, in-person learners have discussed, online learners have paused the video and are now continuing because they think they know the answer. We've got a better visual of this now, so what do you think, Emma? That is one possibility, yes. So again, this is the whole entire casserole. Do I need that whole pan? I only need half of that pan. So the length or width, however you want to call it, this is still going to be 9 inches tall, right? But now I only need half of this, which is going to be 9 inches, right? So one pan that would work would be a 9 by 9 inch pan. Is that the only possibility? I have a few others. Okay. Let me get my drawing ready. Chandon, what do you think?
Okay, I think that they could do a 4.5 by 9.
Yeah, we could do a 4.5 by 9. So that's what this pan would look like, right? Oh, no, not by 9.
By other numbers.
It wouldn't be 4.5 by 9. It would be 4.5 by 18. Yep. Because, so let's address what you said, though, because I fell for it. If I'm cutting all of it in half, right? So I'm cutting it in half this way, and I'm cutting it in half this way. How much am I really using? A fourth.
But just imagine if you didn't do it Emma's way and my way.
Yes, if we didn't do it both ways, then how tall is this pan going to be? 4.5 inches, right? Because half of 9 is 4.5, and half of 18 is 9. But why are we doing half of 18? We're not. Okay, good. I was not paying attention to my own math. Okay, so the dimensions of the second pan would be 18 by 4.5. Which pan do you think is going to be easier to find? A really long and skinny pan or a more square pan? Probably the 9 by 9. Okay, 5 times the amount. This is the tough one. 5 times the amount. Discuss with your groups and pause the video. See if you can think about it. All right, this one's a little bit harder. 5 times the amount of casserole. So I've got 5 casserole pans all lined up. But if instead of having 5 different casserole pans, I wanted just one casserole pan. Is there a casserole pan that has this weird shape? No. So I've got to figure something out, right? So what could I do with this weird sort of piece here? We've got some options. What would you do, Hagen? You might be right. However, I want to address this question that I asked here. Since I can't have this weird sort of shape on the end, what could I do with it? Let's go to Gavin R. We could split it in half, because if I split this in half, now I've got half of it here, right? And half of it here, but what could I do with that half? I could just take it down there, right? And they would be the same size because it's halfsies. So let's figure out those dimensions now. This is 18 and 18 again. And how much is this half right here? Because this part is gone now. That's 9. Good. And this was 9 inches and 9 inches. So let's add it all up. 9 inches plus 9 inches is equal to 18 inches. And 18 and 18 is 36 plus 9 more. 45 inches. So 18 inches by 45 inches. Hagen, is that what you said? Awesome job. Is that the only possibility? No, there's others, but for the sake of time, we're going to go ahead and be done. And I'm going to skip this one here too, just because we're running out of time. What we're going to do is we're going to move on to our summary page. So summary, please, we are highlighting. I need those voices off. Remember, we are recording and the online students are hearing how rowdy you are. Voices off. Lesson 5 summary. All ratios that are equivalent, A to B, can be made by multiplying both A and B by the same number. Let's discuss for a second. Multiplying both by the same number. We also said in our own that this could also be dividing, right? Can we divide by the same number? Yes. So multiplying or dividing by the same number. However, although that is all 100% perfectly true, let's make some connections here. If I divide by 3, I can change that to a multiplication problem, right? Divide by 3, I can change that to a multiplication problem. Let's think about that. We've seen this before. Dividing by 3 is the same as multiplying by, hands up, let's see. Good, Naim? 1/3. Do you see that connection? Dividing by 3 is the same as multiplying by 1/3. What if I'm dividing by 2? Dividing by 2 is the same as multiplying by, Ryan? 1/2. You got it. Are you seeing the connection? That when I divide by a number, I can always change it to a multiplication of like 1 over that number. So 3, 3, we're just flipping it. 2, 2, we're just flipping it. So here's one that we haven't seen before. If I had dividing by 9, that is going to be the same as multiplying by, hands up, let's see. Dividing by 9 is the same as multiplying by, who have I not called on yet today? Luke. 1 over 9, 1/9. You got it. Easy peasy then, right? Okay. So that's why this summary just said multiplying, because even if I am dividing, we can change it to multiplying by a fraction. And let's keep on reading. For example, the ratio 18 to 12 is equivalent to 9 to 6. Because both 9 and 6 are multiplied by the same number 2. 6 times 2 is 12. 9 times 2 is 18. We can multiply by a fraction, because multiplying by 1/3 is the same as dividing by 3. So 6 times 1/3 is 2. 6 divided by 3 is 2. And 9 times 1/3 is 3. And 9 divided by 3 is 3. So again, we see that multiplying by a fraction or dividing by a number. Is 18 to 15 equivalent to 9 to 6? Well, let's see. 9 multiplied by 2 is 18. 6 multiplied by 2 is 12, not the 15. That's why it says nope. Okay, that's it for your summary. Your homework, ladies and gentlemen, is the Unit 2, Lesson 5, practice problems. Practice problems. Okay, let's finish up with our cool down. The cool down says, write another ratio that is equivalent to the ratio 4 to 6. So we have this ratio 4 to 6, and since I'm a big 7th grader, a big kid now, we're writing that 4 to 6 as a fraction. So write another ratio that is equivalent. Pause the video and make sure that that happens. And again, we could have done any number of things to find a ratio that is equivalent. As we saw in our summary, we can multiply by the same number as long as we do it to both parts of that ratio. We can also divide by the same number as long as we do it to both parts of that ratio. So I like to simplify if I can. So I'm actually going to divide by 2. 4 divided by 2 is equal to the number 2. And 6 divided by 2 is equal to the number 3. Now again, there are so many other options that we could have chosen, so I will show you just one more to make sure that we really have a good understanding of this. We can also multiply up. So I'm going to decide, just for fun, I'm going to multiply by 9. Which means that I need to multiply the other part of the ratio by 9. and 4 times 9 is equal to 36, and 6 times 9 is equal to 54. So we also could have had this ratio 36 to 54. How do you know that your new ratio is equivalent? Well, I showed all of my work here. I showed that I'm doing the same thing to the top and to the bottom. I'm dividing by 2 and dividing by 2. Or here I'm multiplying by 9 and multiplying by 9. So really, it says explain or show your reasoning. I showed my reasoning right here. I showed all of my work. If I didn't, then I would have to explain by saying something like, whatever I did to one part, I did to the other. Or I multiplied both parts of the ratio by 9. And that also explains the same reasoning that I showed up above. Again, that's it for today. Please remember you do have your practice problems, and online learners, you also need to enter that cool down in Canvas as well. So cool down has to be done today, and the practice problems can be done another day, but I really strongly encourage you to get it done today so that you don't fall behind. That's it. We'll see you next time.